Welcome back, everyone. Thank you so much for supporting the channel. Today's lesson is going to be on the nucleophilic addition-elimination mechanism and is part of a wider series of videos I've produced on organic mechanisms. The links for all of those lessons are in the description below, so please do check them out. They will be very helpful for your revision. With that said, let's take a look at today's question. A nucleophile is a species with a lone pair of electrons that is attracted to something positive, known as an electrophile or an electrophilic center. So the nucleophile in this case is the hydroxide, and as you can see, it has a lone pair of electrons. The electrophilic bit that it's attracted to will be the dipoles on the carbonyl of the acyl chloride, which is what this molecule is. So the addition bit is where the nucleophile adds to the molecule, and then it's just abbreviated here, the elimination bit is when something is kicked out. So if you look at the product there, you can clearly see that the chlorine must be the thing that is kicked out. So that's what's called the leaving group. So let's take a look at the steps. So in the first part, the lone pair on the hydroxide is drawn to the delta positive, and then that pushes the electrons up to the oxygen of the C double bond O. Then that takes us through to this tetrahedral intermediate. Then in the next stage, the lone pair of electrons drops back down, and the chlorine is then ejected to form the product, which is, as you can see, a carboxylic acid, ethanoic acid, and then the chloride ion has been released. So you'll see that this question is 4 marks. So let's put green text next to what the marks would be. So it's always a mark for 1 arrow there, the second one there, also for the presence of the dipoles. Then the third mark would be the electrons dropping back down, and then the fourth with the chlorine being kicked up. Right, that's the first example. Let's take a look at the second. We have a unsaturated acyl chloride. Unsaturated means containing a double bond or a triple bond or a benzene ring. And the nucleophile is what's highlighted in red here. Okay, so the name of this species here is called sodium ethoxide. And just like sort of sodium hydroxide, it's ionic and it's composed of CH3, O-, and then obviously the Na+. And like all group 1 ionic compounds, they completely dissociate in solution. So it provides a high concentration of the CH3, O- to act as the nucleophile. So let's take a look at the steps again. So the benzene ring, by the way, it doesn't do anything. It's just attached to the acyl chloride, which is the reactive part of the molecule. So dipoles, let's put them in. So the delta positive is on the carbon, delta minus on the oxygen. And then the same as before, we have the CH3 and then the O-. Negative charge drawn to the delta plus, electrons kicked up onto the oxygen. Then that goes through to the CO- chlorine and then OCH3. Then the lone pair on the oxygen drops back down, and then the chlorine is ejected to give the product plus NaCl. So let's see where that's coming from. So we learned from the previous example that chlorine minus is kicked out, and then sodium is going to be present in the solution anyway because of the fact that it's coming from the starting material, the nucleophile, and so naturally they combine, and then that would be written as sodium chloride as the other product. So I hope this was helpful, and if you have any questions, please comment down below, like and subscribe, and I will see you in the next one.